Hello everyone, in this video we're going to talk about linear equations. So what are linear equations? Linear equations can be described as algebraic expressions whose among its terms we can get a highest possible degree of 1. And if you would collect all possible points or all possible solutions of the equation, you would produce a straight line. Examples of linear equations are as follows. So these are examples of linear equations. The structure of the linear equation is very simple, yet a very powerful tool for analysis. One of the key applications of linear equation is finding the relationship of a particular quantity with respect to another quantity. Or simply, we can draw a linear relationship with one variable with respect to another variable. Once we determine the linear equation that governs the relationship between the two variables, we can now predict the value of the first quantity with respect to the other quantity. The following graph will show you quantities that has linear relationship. On this graph, you will see that the total cost of production is related to the number of units produced with respect to a particular fixed cost. On this second graph, you will see that your asset, its book value, depreciates over a period of time. And similarly, it is linear by nature. And on this third graph, you will see that the demand equation and the supply equation are also linear by form. So what are the properties of linear equation? So for instance, we are given y equals 2x plus 3. So we know that the graph of this equation is a straight line. So for instance, we're going to graph this equation. So we're going to determine several points. So for instance, if we set x be equal to negative 2, so the value of y is, so negative 2 times 2 is negative 4 plus 3 is negative 1. And if x is equal to 0, the value of y is equal to 3. And if x is equal to 2, the value of y is equal to 2 times 2 is 4 plus 3 is 7. So we need at least 2 points to determine the graph of a line. So if x equals negative 2, the value of y is negative 1, so at this point. And then if x is equal to 0, the value of y is positive 3. And if the value of x is equal to 2, y is equal to 7. So if we're going to connect these points, we're going to produce a straight line. From this graph, we can describe the properties of linear equation. So the first property is there are infinitely many points in a line. So although we have plotted only 3 points satisfying the equation, but actually there are infinitely many points within the line because the arrowhead of this line indicates that the line is extended indefinitely. So there are infinitely many points within the line. Also, line has a property called slope. So the slope refers to the steepness of the line with respect to the horizontal axis. Mathematically, you can define slope as m is equal to change in y over change in x. For instance, we consider 2 points in the line. So for instance, this is point 1, which has a coordinate of x1, y1, and point 2, this point, which has a coordinate of x2, y2. The change in y refers to the vertical distance between the y coordinates. And the change in x, or delta x, refers to the horizontal distance, or the distance between the x coordinates. And the ratio of these two quantities, or two distances, refers to the steepness of the line, or simply the slope. Sometimes it is called as the gradient of the line. So for this case, the value of the slope is, so this point has a coordinate of 2 and 7, and this point has a coordinate of 0, 3. So change in y is actually the difference between y coordinates, or y2 minus y1, and the change in x is the difference between x coordinates, x2 minus x1. So given these points, so y2 is equal to 7 minus the value of y1 is 3 divided by x2 is equal to 2 minus x1 is equal to 0. Therefore, the slope is 7 minus 3 is 4 divided by 2 minus 0 is 2, and the value of the slope is equal to 2, which is actually this value. Okay. So this parameter of this equation is the slope of the line. There are several possible values for the slope. It could be positive, 0, negative, and even undefined. So what are the instances for those values of the slope? So this is an example of a positive slope. So it is a rising graph. Okay. Whenever the graph of a line is rising, its corresponding slope is positive. On the other side, if the graph of the line is downward or falling, so from a higher level on the left side going downward on the right side, so the value of the slope of that particular line is negative. It is also possible that the value of the slope is 0, since the slope of the line refers to the amount of steepness with respect to the horizontal. When the line is actually on the horizontal, for every point in the line, y is always constant. Okay. Therefore, change in y is equal to 0. So 0 divided by any number is equal to 0. And lastly, the value of the slope could also be undefined or infinite. So again, referring to the formula of the slope, so this would become, any ratio would become undefined if the denominator is equal to 0. Therefore, the value of x2 minus x1 is equal to 0. And that implies that x2 and x1 are the same. or the same value. And that only happens when the line is a vertical line. So this vertical line, so the value of y changes, but the value of x remains the same. So any point within this line, you take the difference of any point or any coordinate x2 and x1, you take their difference, that is always equal to 0. So particularly on this example, so the line passes at x equals -2. So any point within this line, the x's are always equal to -2. So the difference is always equal to 0. Another property of linear equations are its intercepts. The intercepts are points within the graph where the line touches the y or the x-axis. So for this case, we have a y-intercept and an x-intercept. Particularly on this example, we can see that the line touches the y equals 3. And it touches the x-axis at point, you can estimate this as -3/2. So therefore, the y-intercept of this line is equal to 3, and the x-intercept is equal to -3/2. We can refer this as b later on, and this x-coordinate as a. So again, referring to our original equation, our original linear equation, we have this parameter 3, so which is the y-intercept of the line. Again, as a recap of the properties of the line, so one is there are infinitely many points in the line. So as indicated by the arrowheads, it's extended indefinitely. A line has a slope, which refers to the steepness of the line with respect to the horizontal. And then a line has intercepts, which are the x-intercepts and the y-intercepts. And later on its application, you will see that each of these properties will have their corresponding applications on our future topics on this subject. Linear equation may take different forms. So the first form we're going to cover is the slope-intercept form. So the characteristic of this form, so the line will show its slope and its intercept. So the form takes y equals mx plus b. So again, this is called the slope-intercept form because the equation has m, which is the slope of the line, and b, which is the y-intercept of the line. So that's why it is called the slope-intercept form. So for instance, you are given a value of -3 and b is equal to 5, then the equation of the line is y equals -3x plus 5. Another common form of linear equation is the standard form. So the standard form is of this form ax plus by is equal to c, where x and y are your variables and a, b, and c are any real numbers. And as for convenience, we're going to set the value of a as a non-negative integer. So example of an equation in standard form is 5x plus 3y is equal to negative 7. So this form is in standard form. So a is equal to 5, b is equal to 3, c is equal to negative 7. So they are all real numbers, and a is a positive integer or a non-negative integer. A counterexample of a standard form is so this is not in standard form since a is a negative number. So to convert this into a standard form, we're going to multiply both sides by negative 1. Then this will give us 3x minus 4y is equal to negative 3. The third commonly used form of linear equation is the point-slope form. Given by y minus y1 equals m times quantity x minus x1. It is called a point-slope form because for these cases you are given a point which has a coordinate of x1, y1, and the slope of the line. You can determine the equation of the line given these properties. So for instance, you are given a point of 5, negative 3, and a slope of m is equal to negative 2. So plotting this given to our point slope form, so this is our x1 and this is y1. So substituting these values, so y minus negative 3 equals, the slope is negative 2 times x minus x1 is equal to 5. Simplifying this equation will give us y plus 3 equals negative 2x plus 10. Then transpose positive 3 to the right side, so y is equal to negative 2x plus 10 minus 3. Therefore, y is equal to negative 2x plus 7. So this is our corresponding equation given these properties. So this is in standard form. So we have derived its equivalent slope-intercept form. And we can also convert this into a standard form. So transpose this x part to the left side will give us 2x plus y is equal to 7. So this is in standard form. And again, this is in slope-intercept form. Another form of equation which are less popular forms are the general form. General form is very much similar to the standard form. So the general form is ax plus by plus c is equal to 0. In other references, this is also called standard form, but for this case, we're going to call this as the general form. So this is the parameters a, b, and c are also any real number. Again, as for convenience, we're going to set a to be a non-negative integer, and c here is a constant. Okay? So any number is equal to 0, so we're referring to the general equation or the general form of the equation. The next form is the two-point form. So the two-point form is actually an extension of the point-slope form. So the two-point form is given by y minus y1 equals y2 minus y1 over x2 minus x1 times the quantity x minus x1. Okay, so as I've said earlier, it's an extension of the point-slope form. So if you remember, the point-slope form is equal to y minus y1 equals m quantity x minus x1. So actually, this ratio is the slope of the line. So particularly in this form, you are given 2 points instead of a slope and a point. So for example, you are given 2, -1 and 5, 7. You can determine the equation of the line by directly substituting these points to this two-point form, referring this as x1, y1, this point as x2, y2, or vice versa. Okay, this can also be x1, y1, and this is x2, y2. So that's one possible step. Second step is, given 2 points, you can determine the slope, and then you can proceed to the point-slope form. The last form we're going to cover is the intercept form. Again, intercepts are points where the line touches the x-axis and the y-axis. So the x-axis, the x-intercept is the value of A, and the y-intercept is the value of B. So the intercept form takes x over A plus y over B is equal to 1. So this is the x-intercept, this is the y-intercept, and one of the unique characteristic of the intercept form is it is equated to 1. Okay? So if you're given intercepts of the line, so for instance, you have an x-intercept of 3 and a y-intercept of 5, we can determine the equation of the line having these intercepts. So substituting these values on this form, A is 3 and B is 5, this is equated to 1. So x over 3 plus y over 5 is equal to 1. So this is actually the intercept form having these parameters. So from this form, we can transform this into other forms of equation. So first, we can multiply the least common multiple of 3 and 5, which is 15 on both sides. So this will give us 5x plus 3y is equal to 15. So this is the standard form of this equation. So x over 3 plus y over 5 equals 1 is the same line having a standard form of 5x plus 3y is equal to 15. At the same time, we can transpose this on the other side. 5x plus 3y minus 15 is equal to 0 is the equivalent general form. And then from the standard form, we can convert this into a slope-intercept form. So transpose 5x to the right side. This will give us 3y is equal to negative 5x plus 15, dividing both sides by the coefficient of y, which is equal to 3. So y equals negative 5 over 3x plus 15 over 3 is 5. And this is the slope intercept form. So having a slope of negative 5 over 3 and a y-intercept of 5, which is actually one of the given, which is the y-intercept of this line. To recap, we have covered 6 forms of equation. So the most commonly used forms are the slope-intercept form, the standard form, and the point-slope form. And the 3 less popular forms of equation, which are the general form, the 2-point form, and the intercept form. So you can determine an equation depending on what given parameters. Okay, as your exercises, you can answer the following. Okay. At the end of this video, you can also see the solutions of these exercises. Okay. Happy solving!